today's problem from theory of equation, and this problem is based on relation between roots and coefficient, right? And the problem have total 8 part. We have to find out 8 value of x, and it is given that alpha, beta, gamma are the roots of the equation. This is given by x cube plus px square plus qx plus r. This is equal to 0. Okay. Now we first write from the relation between roots and coefficient. It is clear that summation alpha, this is given by minus p. Okay. This is relation number 1. Summation alpha beta, and this is given by q. This is relation number 2, and the last relation is alpha beta gamma. This is minus r, and this is relation number 3. Okay, and we change the relation number 1, 2, 3 by a, b, c, because our problem, in our problem there will be a number 1, 2, 3. So we rename this relation as a, b, c. Now the first relation we have to prove, this is summation alpha square beta square. Okay, if we write the formula of a square plus b square plus c square, this is clearly a plus b plus c whole square minus 2 into ab plus bc plus ca. Okay, so using this relation we write here by summation notation. This is summation alpha beta whole square. This is given by summation a whole square minus 2 into, it is summation ab. Okay, and we write here this is 2 into summation ab. What is summation ab? Summation ab means alpha beta into alpha gamma, or alpha beta into beta gamma, and it is clear that from summation ab alpha beta gamma may be taken common. Okay, so we write this term as alpha beta gamma into summation alpha, right? So we put here directly from relation b and relation c and relation a, we put here q. This is q square minus 2 into alpha beta gamma. This is minus r, so this is r, this is plus, but here is also a minus p, so it is pr. Okay, so the value of the first relation, this is q square minus 2pr. We write here the answer. This is q square minus 2pr. This is the first answer. Now go to the second answer. What is the second expression? This is summation alpha q beta. We use here the formula aq plus bq plus cq minus 3abc. This is given by a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. Okay, this is well-known formula of algebra, and we use this formula by summation notation as this is summation alpha beta whole cube, right? This is not whole cube, this is summation alpha beta. And in the second term, this is summation alpha square beta square, because this is summation a square and this is summation a, minus this is also summation ab. Okay, and as above, summation ab means alpha beta gamma into summation alpha, so we write here alpha beta gamma into summation alpha. This is the second term, and this term in the right side we get plus 3 abc. abc means a means alpha beta, b means beta gamma, and c means gamma alpha. Okay, so clearly ABC means alpha square beta square gamma square. So we get 3 alpha square beta square gamma square, and getting the result, this is given by q and this is already find out here. This is q square minus 2pr using the first relation, minus this is alpha beta gamma. This means minus r and minus p. So pr we get, this is pr, okay, plus 3, this is given by r square. So we get qq minus 3pqr plus 3r square. This is the second result. We write here, this is qq minus 3pqr plus 3r square. Now for the third expression, we write first expression number 3. This is summation beta plus gamma minus alpha whole cube. And we can write this is alpha plus beta plus gamma minus 2 alpha whole cube, right? And this is given by summation. This means summation alpha. So this is minus p and minus 2 alpha whole cube, and this is minus summation p plus 2 alpha whole cube, right? Now if we expand this whole cube minus summation, this is given by pq plus 3p square into 2 alpha plus 3p into 4 alpha square plus 8 alpha cube, right? This is the expansion, and this gives minus summation pq means 3pq, because we get p plus 2 alpha whole cube, p plus 2 beta whole cube, and p plus 2 gamma whole cube. So we get 3pq, and from here we get this is given by 6p square into summation alpha. We put the value of summation alpha from here. Also we get this is 12p into summation alpha square, okay, and the last one is 8 into summation alpha cube. Now we first find the value of summation alpha square and summation alpha cube. Then putting the value, we get the complete result, right? Summation alpha square. This means this is very easy formula. So summation alpha whole square minus 2 into summation alpha beta, and this is given by, we put this is p square minus 2 into summation alpha beta means 2q, okay, this is 2q, and summation alpha cube we put this formula. This is given by summation alpha here into summation alpha square minus summation alpha beta plus 3 alpha beta gamma, right? And this is summation alpha means minus p. This is summation alpha square, we already find, this is p square minus 2q minus summation alpha beta, this means also q, plus, sorry, this is minus 3r, because alpha beta gamma, this is minus r, okay. So the result is minus pq plus this is 3pq, p and q, 3pq minus 3r, okay. Now we put the value of summation alpha square, summation alpha cube, and summation alpha. We get minus 3pq plus 6p square into summation alpha means minus p plus 12p into summation alpha square. So this is p square minus 2q plus 8 into this is summation alpha cube. So we get minus pq plus 3pq minus 3r, right? So this is 3pq minus 6pq plus 12pq minus 24pq minus 8pq, and this is plus 24pq, and this is minus 24r. We get cancel out 24pq, 24pq, and the result is minus, this is 12pq, this is 8pq. So we get 4pq here, and this is plus 4 and plus 3, this is 7pq. So we get 7pq minus 6pq. So we get the result pq pq minus 24r, that is our result is 24r minus pq. Okay, so our third answer, this is given by 24r minus pq. This is the answer of the third expression. Now for the fourth expression, this is given by summation alpha to the power 4. We can write summation alpha to the power 4 in the form of summation alpha square whole square minus 2 into summation alpha square beta square. As we write summation alpha square, this is equal to summation alpha whole square minus 2 into summation alpha beta. Using the same relation, we write this. Okay. Now we already find out the summation alpha square, the value of summation alpha square. Here we again deduction done. Summation alpha whole square, this is given by p square minus 2 into this is q. Okay, so we put here p square minus 2q whole square minus 2 into the value of summation alpha square beta square. We already find in the first, we put here q square minus 2 here. So getting the result as p to the power 4 minus 4 p square q plus 4q square minus 2q square plus 2, sorry, this is 4pr, and getting by simplified p to the power 4 minus 4 p square q, and this is given by plus 4 pr, and this is plus 2 q square. Okay, this is the value of the expression summation alpha to the power 4. We write the result here. This is given by p to the power 4 minus 4 p square q plus 4 pr plus 2 q square. Okay, this is the value of fourth expression. Now we go for the relation number 5. This is most easy expression of this problem, and relation number 5 is summation alpha square beta square gamma. Since there is only two variable alpha beta gamma, so we can take in common alpha beta gamma from this expression and left are alpha beta. Okay, so we get this is minus r into summation alpha beta, this means q, right, and the value is minus qr. We write here the value of minus qr. This is the value of 5. Now relation number 6. This is given by summation alpha minus beta whole square into gamma. We first expand the square. This is alpha square minus 2 alpha beta gamma minus, sorry, plus beta square into gamma, and getting the result as this is summation alpha square beta, because alpha square gamma beta square gamma is in the same term. Okay, this is given by alpha square beta minus this type of term, this is 2 into alpha beta and not gamma here, and by multiplying we get gamma. So we get this type of term in 3 of number. Okay, because in the first term we get 2 alpha beta gamma, in the second also 2 alpha beta gamma, and in the third. So we write this is 6 alpha beta gamma. Okay. Now we write the expression, this is summation alpha into summation alpha beta. If we count the number of terms in the product, in summation alpha there be 3 terms, and in summation alpha beta there must be 3 terms. Okay, so we get by product 9 terms. But in summation alpha square beta, there are only 6 terms. So there are 3 terms extra. What are the type of this term? The type of this term is given by alpha beta gamma. Okay, because if we see alpha plus beta plus gamma into alpha beta plus beta gamma plus gamma alpha, then we get alpha square beta, alpha beta gamma and alpha square gamma. This and this term in the summation of this, but this is the extra term. Okay, from here we get also one extra term, from here we get also here. Okay, so we write here this is minus 3 alpha beta gamma, and already here 6 alpha beta gamma. Okay, now by putting summation alpha, this is minus p, summation alpha beta, this is q, minus 9 into alpha beta gamma, this is given by minus r. Okay, so 9r minus pq. Now we write this result inside of 6, this is 9r minus pq. For relation number 7, this is given by summation alpha minus beta whole square into gamma square, and expanding we get the result, this is alpha square minus 2 alpha beta plus beta square into gamma square. Okay, and when we multiply by gamma square we get two same type of term, this is alpha square gamma square and beta square gamma square. Okay, and in another two term we get also this type of fourth term. Okay, so we get in summation, by expanding the summation, 6 type of term, alpha square gamma square and so on. So we get here 2 into summation alpha square beta square, because in summation alpha square beta square we get only 3 terms, this is alpha square gamma square and beta square gamma square. Okay, and we get this expression 2 times here, and from here we get minus 2 into summation alpha beta gamma square. Now we put the value of summation alpha square beta square, we already find in the first expression, this is q square minus 2pr, and this is very easy, 2 into alpha beta gamma into summation alpha, and this is 2q square minus 4pr minus 2 into, what is the value of alpha beta gamma? This is minus r, so this is plus r into this is also minus p. So we get this is 2q square minus 6pr. Okay, so we write here this value 2q square minus 6pr. For the last, that is for the 8th expression, we first write this first term in the first bracket, this is summation alpha minus 3 alpha. In the second first bracket, we also write summation alpha minus 3 beta, and this is also summation alpha minus 2 gamma. Right? So we put here summation alpha means minus p, and taking minus from each of them, so we get minus p plus 3 alpha into p plus 3 beta into p plus 3 gamma. Okay, this is not 2, this is also 3 gamma. Now multiplying this 3 term, we get directly multiply here pq plus, we get p square into 3 into summation alpha, because when we multiply pp and 3 gamma, pp and 3 beta and pp into 3 alpha, so we get this result. Now we get this is p into 3 alpha 3 beta, that is 9p into summation alpha beta, and the last term is 27 alpha beta gamma. Okay, this is easy multiplication, so we putting the value pq plus 3p square into minus p, because this is summation alpha, plus this is 9p into this is q, and the last is 27 into r, this is minus because alpha beta gamma is minus r. So the result is 27r, and this is given by plus 3pq minus pq minus 9p into q. So we get 27r plus 2pq minus 9p into q. Okay, we write the last result here. This is 27r plus 2pq minus 9p into q. Okay, very lengthy problem but interesting and important problem of theory of equation. Thank you for watching and keep watching Math A to Z.